So section 10, we're going to talk about relations, okay? This is the last section of chapter 3. We're going to graph relations and determine when relations are also functions. So we already talked about functions and more specifically linear functions. Now we're going to talk about the more general case of just any relation, which is just any set of ordered pairs, okay? So any set of ordered pairs doesn't necessarily have to be a function, right? We already talked about functions as being distinctly a relation in which each input is different. Okay, you can't have two outputs going along with only one input. Okay, now the test that that was so dumb. Okay, so what we use to test whether or not a relation is a function is called the vertical line test. You've probably heard it before. So if you look at a graph, right, a relation is a function if, this means if and only if and only if. Okay, it's a logic term that you're going to see. It's basically telling you a definition. Okay, so if and only if any vertical line intersects the graph at most one time. So if you hit a graph twice at any point, then it blows up the whole thing and it's not a function. All right, it's still a relation, not a function. All right, so this first one we've got good, 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 not hitting the graph at all, that's fine. Hit the graph once, right there, that's fine. Boom, blows up. You hit the graph twice, not a function. Second one, good, 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 boom, blows up. No, not a function. Third one, it's all good everywhere. That one's good. Fourth one, all good. These vertical lines, all good. All right, these two right here on the brink, all right, the reason those are good is because you see that one of the circles is open. It's because one of them is open. It's not actually hitting the place twice. So that one is also good. So in these little guys, we're going to state the domain and range, tell whether the relation is the function. The relation is a function. Now relations, remember, is just any set of ordered pairs. So this is one way to represent it as an ordered pair, or a set of ordered pairs. So the domain is just all the x's. 1, 2, 3, 4. That's a bad squiggly. And the range is just all the y's. 2, 1 are the only options. So does it matter that there are two 2's for the y's and two 1's for the y's? No, it doesn't. Right? That doesn't bother us. It's only if you double up on x's. Right? So if you double up on x's, it's not good. If you don't, then you are all good. So the answer is yes, it's a function. All right, it's easier to see here with the mapping diagrams. All right, the first one is always the domain. The second one is the range. All right, it's really simple to see because if you have two arrows coming out of anything in the domain area, it blows up. If you have two things coming into the range, don't even worry about it. You don't even need to worry about the range. Just don't even look at it. Okay. All you're going to do is stare at this and tell us if it's a function. Well, there's two arrows coming out of the one, so nopees, it is not a function, and I obviously labeled the domain and range already. Third one, vertical line test for a graph. All good? Yes, it's a function. Okay. Now, the domain and range, it's pretty unclear here. If I erase this stuff so we could see it, you can't exactly tell because there's no arrows on the end, but it looks to me like the domain is all reals. Right, so the x's, when you're spanning this, right, it looks like it's never going to stop. All right, but the range, it does look like there are bounds, right, because you're going up to 4 and down to negative 4. So it pretty much looks like negative 4 is less than or equal to y, which is less than or equal to 4. So 4 could be anywhere between negative, or y can be anywhere between negative 4 and 4. That's what it looks like. Okay, so some crazy graphs. All right, this is just going to help us graph absolute values, graph things that are not very straightforward. You can't just plug into a formula. Okay, so we have the absolute value of y equals the absolute value of x. Just make a table of values. All right, t-charts are the way to go. So xy table. Let's do negative 2, negative 1, 0, 1, 2. All right, plug those in for x, figure out what y is. So the absolute value of x, or absolute value of negative 2 equals the absolute value of 2. So negative 2 here could also be, so if negative 2 is x, so I need to know when the absolute value of y is 2. Well, there's two answers to that. It's 2 or negative 2. Right? Well, that's pretty messed up. That already tells us this is a pretty crazy graph. So you go back or go left 2, you got to go up 2 or down 2. Now, obviously, that automatically tells us that this is not going to make sense as a function, so it's definitely not going to be a function. All right, negative 1 is going to be the same way, 1 or negative 1. 0 is just 0. 1 is 1 or negative 1. 2 is 2 or negative 2. Okay, so you get the idea of what this graph's going to look like. It's going to be, oh man, that is not close. Eraser. Okay, I'm going to draw this better this time, I promise. Ish. Okay, it's going to come out all 4 corners. I'm spinning around my iPad doing this like an idiot. I can't draw. Okay, so you get the idea. It's an x through the whole graph. Right? Is it going to be a function? Definitely not a function. All right, the second one. Let's do another t-chart. Negative 2, negative 1, 0, 1, 2. So, plugging in negative 2 for x, and we'll get 1/2 for y, 1 for y, 1 over 0. That doesn't work, so nothing, because 1 over 0 doesn't work. 1 over 1 is 1, 1 over 2 is 1/2 again. So I could graph these. 0, I'm not graphing anything. I know I'm not getting all the way there. 1, 1. That's so bad. 2, negative 1. Maybe I should use bigger graphs next time. Negative 1, 1, negative 2, 1/2. Okay, so it looks like what this graph is actually going to do is it's going to get close and not reach it. And down at the bottom, it's going to get close and not reach it. Okay, so it's going to look like that. All right? Now, that's pretty messed up. Is it a function? Yes, it still is a function because your vertical line test is going to pass for all of these. Okay? Now we're going to graph each relation if x and y are integers and state if it is a function. Good. So for 6 and 7, these are just some points. All right, so we can just plot them on there. 1, negative 2, 2, 1, 1, 2. Right? Is it a function? No, because this is a really easy vertical line test, but you see here at 1, right, there's 2 1s in the domain, so it's not a function. All right, for 7, we've got one absolute value of negative 2, which is just going to be 2, 1, 2. 2, or absolute value of negative 2, which is 2, 1, and 1, 2. So the 1, 2 appears on there twice. Once again, 2 inputs is the same. No good. Absolute value of x plus absolute value of y is less than 3. Okay, so remember, this is saying that the x and y are both integers. Okay, so I know that 0 plus 0 is less than 3, so the origin works. Okay, well, I could have up to, you can't use 3, right? You're never going to be able to use 3. X and y. 0, 0 works. All right, you're not going to be able to use 3 because we need less than 3. Okay, so we could try 1. If x is 1, then y could be 0, 2, 1. Oh, no, it can't be 2. Gosh, what am I thinking? No brain. No brain at all. 1, 1, right? This could be 1, and that could be negative 1. All right, so there's a whole lot of 1s. We already see 1, 0. 1, 1, 1, negative 1. All right, so we already see that it blows up. All right, you'll actually be able to create this whole box around here with your t-chart. All these points work just fine, okay? And that's your graph is going to look like that. And is it a function? It's obviously not a function. No. Lastly, x squared plus y squared is less than 6. This is actually a circle, okay? So it might be tough to see, but you have a circle with a radius of less than 6. So what that means is, or less than the square root of 6. So you could use 1 and 1. square root of 6 is between 2 and 3, right? So our radius is between 2 and 3. Make this dotted line. Good dotted line. Everything in the middle of there is shaded. Okay, so all of those are points. Right? This is big closed-in circle. So that's clearly not going to pass the vertical line test. It's not a function. All right, that's it.